Hello everyone. I'm Dana Rus.
Hello everyone.
I'm a principal data engineer.
I'm Dana Rus.
Hello. And today I will present you our AWS adoption journey, automation and operation at scale. Who we are? Betfair Romania Development. It's our local company. It's based in Cluj, and it's our development center of excellence for data and analytics, gaming, marketing and customer management. We are part of PediPower Betfair as a European business, and PediPower Betfair is part of Flutter as a global overall group. We are a large company. We have around 8,000 employees and a revenue of 1.9 billion pounds. As a split, a mix of revenue for Flutter Entertainment, you can see here on the slide, on this slide, on the left side, on the right side, sorry. The revenue split by market and channel. European online, you can see that it has the biggest portion of our revenue, 51%. On the left side, you could see our brands, market, products, and channels. The main brands we look after are PediPower and Betfair. Those numbers are even bigger than this, actually, because recently we announced a new merger with PokerStars, but those are the details we can share with you at this point. And I said a new merger because in 2016, actually we had another merger between Betfair and PediPower, and for us was a unique opportunity to move the data from on-premise to cloud. At that point, we had two data warehouses, one in Oracle on Betfair side and one on SQL Server on PediPower side. And we wanted to give it a try to see how cloud works and what kind of benefits would cloud give us. And as part of Integrated Data Platform, IDP, we've leveraged tens of AWS services for different purposes to see if those meet our needs. And we decided to have a strategic engagement with AWS product teams because they had AWS cloud automation, efficient account management, and product engagement to suffice our unique needs as business. So we started the IDP migration to cloud in 2016 in the second part. As a first use case, we had a set of large data web logs that we were processing till then in Oracle data warehouse. And to process a day worth of data for us took around 1.5 days. And we wanted to give it a try, what will happen in cloud with an EMR cluster. So we've processed the same data set with an EMR cluster, and we lowered down the processing to 20 minutes. And the queries on top of that data set decrease, the execution decreased from hours to less than a minute. So after the merger, we decided to extend the footprint in AWS, and we leveraged S3 and Redshift as strategic technologies for our data warehouse as part of IDP project. As a next step, we looked at security. We wanted our data to be secured in cloud. We discussed with AWS teams to align to the best practices here. We just wanted to see that our data transfers are secure, and when we store the data in cloud, we have everything that a security team will demand us, let's say. And we decided to adopt new services like KMS for our PI data. When we land the data in S3, we encrypt it with KMS. And when we connect to the console, we used multi-factor authentication. In H1 of 2017, we upsized to 20 node our Redshift cluster, and we continue onboarding new data sets. At this point in time, our Redshift cluster has around 30 terabytes of data and 90K daily queries on average. We adopted new strategic services for instance, for our low latency operational reporting. We adopted Amazon RDS. But not only, also EC2 for other purposes. As a next step, we are now focusing on automation. And in H2 of 2017, we upsized again Redshift to 28 nodes. If we want to compare with the previous year, when we only had 6 nodes, it's a huge huge difference. Now our data warehouse is quite large, and all our data joined from both of the brands, Paddy Power and Betfair, is now available there, the majority of data. The move to the new node type was a game changer for us. Prior we had DC1, and now moving to DC2 was a big change for us in performance and in user perception. We started building in-house streaming processing framework using new AWS services like SQS and SNS to bring more stream data in our data lake in S3. At this point in time, Redshift doubles in size, and we have around 62 terabytes of data and around 30K daily queries on average. On the first, in H1 in 2018, we started to analyze a new feature, Redshift Spectrum, which allows us to query on top of S3 directly and join the S3 data together with the details we already have in Redshift. Pod was upgraded from RDS to Aurora for improvements. At this point in time, S3 data lake has around 200 terabytes of data, and our largest data sets can be queried from there using Spectrum. We focused more on automation, infrastructure as code, established ways of working with AWS product teams, with a focus mostly on Redshift and Redshift Spectrum. We adopted at that point cloud formation. Aurora has around 8 terabytes of data and a low latency lower than 0.01 seconds. As a next step, we focused on capabilities for advanced analytics. H2 from 2018, we've developed machine learning models and advanced analytics with SageMaker. We focused more on automation. We spin up and down instances automatically, mostly to save money. We save around 10K per month just by doing those optimization and automation. We adopted AWS Kinesis to have to interrogate in-fly streams for operational alerts. For an example would be an alert for retail loss prevention. They wanted to have an alert triggered in less than 2 minutes from the moment then a user places the bet. At this point, Redshift has around 60 terabytes of lean data and around 100K daily queries on average. So we have quite a busy cluster, I would say. Aurora increased also, so around 18 terabytes of data at this point in time. In H1 2019, We onboarded new AWS services like Elastic Load Balancer, DynamoDB, ECS, Glue, Athena. Focusing on advanced analytics usage, automating business processes, and other infrastructure automations. We continue focusing on operational improvements and additional product features. We have a strong partnership with AWS. We have weekly calls with AWS support. We've raised around 50 plus bugs, and with our collaboration, AWS fixed those, the majority of them. We have every 2 weeks we have calls with AWS product team in Berlin and ad hoc meetings with AWS product teams from US. We raised around 20 plus product feature requests. Some of them were implemented and some of them are on the roadmap. We have, from time to time, we have AWS on site here in Cluj with us for different purposes to test different new features. Each 2 weeks, we have calls with AWS management for more strategic discussions, including the strategic meeting from the reInvent at the end of 2019. We've been to Las Vegas to see what's new and to analyze the roadmap with them. We had there in that meeting senior architects, engineers, and product management. Actually, prior this, we kind of hit some limitation on Redshift side, and we asked ourselves if actually Redshift will cope with our new requirements. We needed to onboard new data. We'll have more users on Redshift. Is it Redshift changing fast enough so that will meet our requirements in the future, or should we see other services? And we actually analyzed another service, Snowflake, and yeah, we tested with production data and see if, for instance, if we live in Redshift only ETL and move the users in Snowflake, is it better for us? And yeah, we had on site a team from Snowflake, and we tested with production data for a couple of scenarios, let's say. And yeah, we had good results. But then when we've been to reInvent, we saw the new features that Redshift had, for instance, the new node type, RF3, and concurrency scaling. And we decided to see exactly if Redshift with the new features will meet our requirements at that point in time. So the first half of 2020 was about more machine learning implementation, Kubernetes, stream processing optimization, bigger data sets onboarding, but the biggest focus was on the new features on Redshift, and we've tried to analyze those and see from which we will benefit more. Also, the adopting of Looker, which is the BI tool, which connects directly to Redshift and relies entirely on the performance of Redshift. As a Redshift warehouse evolution, we can see here the steps that we've done after we came back from reInvent. In January, we decided to test as many new features as possible. We discussed with them which ones will we benefit more. And in January, we decided to test RF3, node type, and concurrency scaling, and see and compare the results with the Snowflake solution, and decide on which path to go. As you can see here, in February, we already switched to RF3 and we decided to remain with Redshift. And also we defined some guardrails, as the ones that you see in this slide. Are metrics that we look for to see the progress, the evolution, to see performance improvements after each new functionality that we adopt, let's say. So you could see here when we had switched to RF3, or when we adopted MVs, or when we switched to 16 slices. So we defined it at that point some guardrails, and we monitor it closely to see if the performance improves. And yeah, we have calls with AWS teams, and we monitor those together. In March, we prepare for Cheltenham, our spring racing. It's the biggest event, and we prepare for that prior together with AWS. And also we adopted for some of the processes, some most important processes, the materialized views. In April, we adopted Looker over Redshift, and we started to build some models. In May, we moved from 26 nodes to 16, from 26 slices to 16 slices. So what we've done in February, when we migrated to RF3, we had a cluster of DC2 cluster, 30 nodes, and we've done a cross-instance restore. So in that case, this is cross-instance restore is done quite quickly. But in that case, on RF3, we had an 18 node cluster, but in that case, for each node, we will have 26 or 27 slices, and is not the default number of slices per node. And in May, we wanted to go to the default slices per node, the 16 slices. And also this one, as you can see here on the graphs, had a big impact, mostly on the write statements, but not only. From then, actually, we picked up from January, we picked up a lot of updates, and we continue monitoring the new feature and try to adopt as many as we can. We also tested other features, but not all of them we implemented. To read the graphs, on the left side, we have the total number of queries. We split our queries on different queues with different resources. The application queue is the green one, and the ETL is the yellow one. And the rest, the blue one, are the users, all the users. And you could see here, after we moved to 16 slices, you could see that we can take more and we can execute more queries on the Redshift cluster. Also, if we look down to the average end-to-end query time, after we adopted RF3 node type, we see a great improvement in end-to-end execution of the queries. But also after we move from 26 to 16 slices per node. On the right side, you could see the average wait queue times. And the biggest improvement was when we actually changed from DC2 to RF3 node type. Right. Our platform today, we have around 430 terabytes of data and growing. But this is not only Redshift, it's also S3 and Aurora. 3.5 million queries per month, around 3,000 ETL jobs, 7 live machine learning models, and an average of 500 SageMaker jobs. Thank you. That's it. If you have any questions, please let me know.
Thank you. I want to start by saying really, a great insight into what are you doing there at Betfair, and also by saying thank you for supporting the Women in Tech stage. It was by far the most insightful stage, in my opinion.
Thank you.
And we're going to take a look. But what I want to ask is, how did you manage to keep focusing on everything? Because I saw the timeline. It was about 3 years in which you've implemented so many different things, and
Yeah, well,
also going through mergers and all of that. So
yeah, we are a big team, let's say, and in the past couple of years, we increased the numbers of data and analytics folks. So at the beginning, yes, we were only a couple of teams, but yeah, we expand from this point of view. So we had help. Yeah.
All right. And also what I want to ask, was there a moment when you thought, well, this isn't working. This thing that we've implemented, it's not going to work, and maybe we should stop chasing this? Or
yes, there were
yeah.
features that there were. Actually, we raised one of the features that AWS had was, and they advertised that if we change to AZ64, for instance, we will gain performance of, I don't know, up to 70%. And actually, we've replayed our queries. We've changed some of our structures, the main ones that we mostly query on top, and actually we see degradation actually, and we asked what we are doing different from other users, why we don't see an improvement in our queries. For some, yes, was an improvement, but we saw also a degradation, and we actually didn't go in that direction. So yeah, not all of them, and still the features are refined based on our input. For instance, materialized views is still refining with our help, with our team's help.
So it's basically a bit of trial and error at some point.
Yes, yeah. Exactly.
That's great. Well, our viewers will probably going to start dissecting the whole presentation now and come up with questions along the way. But for now, this is pretty much it. So thank you for being with us again. Thank you for sponsoring Women in Tech stage, and hope to hear from you soon.
Awesome. Thank you very much.
Thank you. Bye.
Bye.